We're going to discuss z-scores. Z-scores are a concept that don't have an impressive name, but it's an extremely useful measure. So the definition of z-score is the number of standard deviations that a given data point is away from the mean. So the mean, and it's how many standard deviations is something away from the mean. Let's do some examples. So let's say, for example, our point is 35, the mean is 29, and the standard deviation is 3. So these are kind of standard deviation lines, I'm going to say. So the mean is, this is the mean over here, and the mean is 29. And what we want to do, if we go up one standard deviation, so if we go up a standard deviation, so now we're at mean plus a standard deviation, and standard deviation is 3, so we're going to be at 32. If we go up another standard deviation of 3, we're going to be at 35, and we could have gone backwards like that. Now our point is 35, and so we can see that 35 is exactly 2 standard deviations above the mean. And so therefore, for x equals 35, the z-score is 2 for that mean and that standard deviation. Let's do another one. So I kept the same mean and standard deviation, so nothing new over there. So we have our mean, and then our mean is 29, 26, 23, 20, 32, 35. So these are our standard deviation apart. Now our point is 20, and we can see that 20 is 1, 2, 3 standard deviations away from the mean. And because it's below the mean, what we actually say is we say that the z is -3. So it's 3 standard deviations away, and it's 3 standard deviations below the mean. So -3 is 3 standard deviations below the mean. If it was +3, it would be 3 standard deviations above the mean. So the third example. So it has changed. So what we have here is, so the mean, this is the mean. So the mean is 29. And if we go up a standard deviation, we're going to be at 4 away. It's going to be 33. But here our x is 30. So we're over here. This is our x. And we can see with the x is that we are actually about a quarter of a standard deviation away from the mean. And so the way we say that is that z is 0.25. So 30 is 1 standard deviation above the mean. And putting that together, we come up with a formula for the z-score. And the formula for z-score is going to be that the z-score is x, we take our value, we subtract the mean, and we divide by the standard deviation. And this is a formula that is surprisingly powerful. It takes into account a lot of information. So the z-score includes information about the mean and about the standard deviation and the actual point that we're having. And so a lot of information is encapsulated in this one z-score value. And it's useful, especially when you get these statistics. That's z-score.